Okay, so we went in pretty in-depth study on arithmetic sequences. So we started off first being able to determine between the two. And then last lesson we went into arithmetic sequences and their series. Remember, series is just a sum of a certain number of terms in a sequence. So today we're going to look more at geometric sequences, use those, and then find their sum. So and remember, we saw this same thing with arithmetic. Those geometric means are those terms in between the terms that are given. And then series is a sum of a certain number of terms. So here is our geometric sequence base equation. It's the term I'm looking for equals the first term, remember A1's first term, times the rate, and then term number is n minus 1. And remember, this is a exponential equation. We just kind of got through with exponential equations. This part has to be done first. Like, I can't just multiply these two numbers together, the A1 and the R. I have to do this part first. Order of operations still very important. So I'm wanting the sixth term. So when n is 6, we know A1 is -3 and our R is -2. And they want to know that what is the sixth term of this geometric sequence. So here's our equation again. I'm going to put it in multiplication there to remind ourselves that that's multiplication. So we would go -3 times -2 to the 6 minus 1 power. So -3 times -2 to the 5th power. -2 to the 5th power is -32, and then multiply those two to get positive 96. So we're multiplying by -2 every time, starting at -3. All right. So here you're looking for the fifth term, so your n would be 5, and I'll let you work that out. So now we're going to write an equation. So we have that equation for someone to find any term in the sequence. So we need to know, we don't know n, because that's going to continue to be n, because we're looking for the nth term. And a to the n is just a to the n there. So our r is 10. Remember, we find our ratio by taking the second term divided by the term in front. Term divided by the term in front. So we could do 10 divided by 5, which is 2. And A1 is 5. So I have a to the n equals my A1, 5, times my R, 2, n minus 1. And again, we cannot multiply that 5 and 2, so that's just it, where there's our nth equation. Here we know that my a to the 5th is 4, and we know r is 3, so we're going to find a1 first. So when we had our 5th term, when we put in 5 for n, we got 4. So let's plug in what we know so we can find our a1, so we can write our equation. So 4 equals a1, which we don't know, r, which is 3, to the 5 minus 1. So we're going to use this term here, the 5th term, so that's where the 5 came in, to find a1, so I can write my equation. So 4 equals a1, 3 times 3 to the 4th. 3 to the 4th is 81. So 4 equals a1 times 81, and then divide by 81. So a1 equals 4 over 81. And you can find that decimal, so then my nth equation would be a1, 4 over 81, times the radius, n minus 1. So not radius, ratio. Sorry, I just got done with geometry. So I'll let you go ahead and do that one. Let's look at finding the geometric means. So here I have 3.12 wanting to find the three means, three terms in between these terms. So we have our A1, and this is first term, second, third, fourth, fifth. So we have our A fifth. So we're going to have to find our ratio so we can plug that in. So let's plug in our equation, 49.92. So we know our last term that we know is 49.92 equals my first term times the r, which I don't know, but I know that when this is my fifth term. So we have 49.92 equals 3.12 times r to the fourth. Let's divide by 3.12. So we get 16 equals r to the fourth. And then remember, when solving exponential equations, we can take the fourth root and r equals 2. So that means we're going to multiply by 2. So 3.12 times 2, 6.24. 12.49. 24.96, and then if I did times 2 again, I should get 49.92. So those are my three terms. So just really working on using that base equation for geometric sequences. So then that leads us to the last part where we're finding the sum. So here are two equations that we have. If I'm given the first term and the term numbers, the number of terms I'm adding together, this one works great. If I'm given the first and last, this works great. So Julian hears a song by a new band. He emails a link for the band's website to 5 of his friends. They each forward the link to 5 of their friends. The link is forwarded again following the same pattern. How many will receive the link on the 6th round of emails? So we want the total amount of people. So we're adding, my n is 6. I'm adding up all of my all of the people in the first 6. We started with 5 people, and we are going up 5 at a time. So every round is 5 more, or 5 times that, those 5. So we're going to use this first equation here. So we have A1 is 5 minus 5 times 5 to the 6, because we want the first 6 terms, over 1 minus 5. So we have and then if we plug that in, we find that the sum would be 19,530. Right, and I'll let you figure out this one. Let's go into sigma, because we noticed last time that sigma relates with our series. So here's geometric. We can tell that because it's exponential. And so there's a few ways that we can do that. We have our A1 is right here if we know our first equation, and there's my R, and my N is, subtract those two, plus 1, remember. So A1 equals 3, R equals 2, and N equals 12 minus 1 plus 1, because we want to include that first one. So all the numbers, so we have 13. So then I can plug that in. So it would be 3 Gotta remember that equation. Sorry, should have written that down. Three minus 3 times 2 to the n minus 1 over 1 minus my ratio. It's just to the n, sorry. My n is 12, not 13. And then I can just go ahead and figure that out. So I have 3 minus 3 times 2 to the 12th divided by negative 1. So that's my total. All right, if you have questions, let me know. Hope you have a great day.